Good morning, everybody. Hope you're all healthy and safe. We are moving on to the next section of our first module, that is on separable equations. So, section 2.2, separable equations. So, in this lecture, we are going to study about what is a separable equation and how to solve separable equation. So, let's see. This is the definition, that is a first order differential equation of the form dy by dx equal to g of x into h of y is said to be separable or to have separable variables. So the word itself suggests, the word is separable, that is we can separate into two or more. So here we have dy by dx is equal to g of x into h of y. Okay, so if I take h of y to the right hand side, so what do we get? We get dy by h of y, right? It will be equal to g of x into d of x. Now if I consider this 1 by h of y to be some other function on y, I can say like p of y. P of y into d of y is equal to g of x into d of x, right? So that is what is called, that is what is meant by a separable equation. That is, I can separate the variables, that is the variables of y along with dy and the variables, the function of y along with dy and the function of x along with dx. So if we have an equation of this form, this is the general form, so I can simplify it and form into this manner. So if we have a general equation, if we have an equation of this form, how can we solve it? That is, how can we find the value of y? It's pretty much simple. We just have to integrate both the sides, right? So that is next step. That is the one method of solution. So a one parameter family of solution, usually it's given implicitly, is obtained by integrating both sides of the differential equation, that is p of y into dy is equal to g of x into dx. So that's what I said just right now. That is, to find the solution, we just have to integrate both the sides of the particular differential after separating the variables. After separating the variables and combining them with the respective dy and dx, we just have to integrate both the sides. Now one thing we have to keep in mind is that while we are integrating, we usually put in, or we usually write down the term of integrating constant, right? So sometimes what happens is we get more than one constants or a multiple of constants. So what we do is, in the end, we treat everything to be a single constant. Okay, the constant of integration will be relabeled again into our convenience. So we can replace all the constants by a single constant. So that is the second point that is mentioned here. That is, the constants of integration will be relabeled in a manner convenient to a given equation. For example, multiples of constants or combination of constants, that is c1 plus c2 or c2 plus c3 plus c4, etc., can sometimes be replaced by a single constant. So that is how we solve a particular separable equation. So this is the case of a separable equation, how do we solve them. So let us see a few examples which are given in your textbook. So here the definition is given to us. That's what we have just now discussed. So if you see, let's see the example. First one is dy by dx is equal to x square y raised to 4 e raised to 5x minus 3y. Okay, let's focus on this one first. So this is our function. Now just see whether we can separate the variables of x, the terms containing x and terms containing y. Of course we can, because we can write this as x square into e raised to 5x into y raised to 4 into e raised to minus 3y. So that is simple, and I can simplify it. So here again you can see, if I consider this as a function of x and y, I can separate it as this g of x into h of y. So this is a separable equation. Now let's move on to the second one. Second one is dy by dx is equal to y plus cos x. So Is there any way of finding finding or forming the differential equation of the desired form? That is, there is no method or there is no way to separate this as a particular function of y into a function of x. Okay, it cannot be considered as a product of the function, so we cannot write it in that manner. So that's why that is not a separable equation. So the first one is a separable equation and the second one is not a separable equation. So this is about the solution, method of solution that we have just now seen. So if you see an example, it will be much more easier. So let's just move on to the first example. That is, we are asked to solve 1 plus x dy minus y dx equal to 0. So it's clearly, you can see that it is separable. So here how can we make it into our desired form? So we'll have taking y dx to the other side and then dividing it by 1 plus x into y, we get dy by y is equal to dx by x, dx by 1 plus x. Okay, so this is the required differential form. So I can integrate both the sides. So integrating both the sides, this will be log y and this will be log of 1 plus x plus some constant. Okay, so here instead of c1, if I take log of c1, it will be much more easier. Taking exponential on both the sides, this is simplifying it. So I have our main aim is to find y in terms of x. Okay, so we have log of y is equal to log of 1 plus x plus the integrating constant c1. So here we have taking exponential on both the sides, we get e raised to log of y, that is mod y. Mod y will be equal to e raised to log of 1 plus mod 1 plus x plus c1, which is nothing but e raised to log of mod 1 plus x into e raised to c1. Okay, or I can write this as 1 plus x into e raised to c1. Now this e raised to c1 can be treated as a particular constant like c. So the solution is actually y is equal to c into 1 plus x. Okay, now as a remark, this is easy, right? Once we are able to separate the given differential equation into the separable, into the differential form, into our required differential form, we just have to integrate both the sides. Okay, and easily we'll obtain the value of y in terms of x. So that is the solution of a separable differential equation. So here again, as I mentioned earlier in the beginning, if I had replaced instead of c1, whenever we have log, if I put this as log of c1, okay, then I will get e raised to log 1 plus x1 into c1, and there will be not this much complication. That is, we just have to write it. We'll get the value to be log y will be equal to log of c into 1 plus x. Log a plus log b is equal to log ab. So from that the value will be this value can be easily determined. So that's our wish. That's what that is the importance that of the second point that I have mentioned in the slide. That is, the constants can be replaced. Here e raised to c1 is a constant, plus or minus e raised to c1 is a constant, integrating constant. So I can replace this by another name or label. So that doesn't matter much. Okay. Now next is another example. In this example, it's just we are trying to solve the differential equation, which is clearly you can see that dy by dx is equal to minus x into y, minus x by y, and the initial value is also given to us, that is y of 4 is equal to minus 3. So while solving, we'll get I'll replace this as this equation as y dy is equal to minus x dx, right? So when we integrate it, this will be integrating y means it will be y square by 2. Y square by 2 is equal to x square minus x square by 2 plus some integrating constant. Or I can replace this as x square plus y square by 2 is equal to c1. X square plus y square by 2 is equal to c1. So I can take the 2 to the other side, to the right hand side. So I get x square plus y square is equal to 2 into c1, right? So I can replace 2 into c1 by another constant, say c square. So I get x square plus y square is equal to c square. So that is the general solution. Now so from this I have obtained the value. I can obtain the value of y, right? Y is equal to, it is nothing but root of c square minus x square. So I have obtained the solution of the given differential equation. Now looking at it itself, we can easily find. Now since the initial value is given to us, we can find the value of c. Okay, that is y of 4 is equal to minus 3. That is when x is equal to 4, y will be minus 3. So substituting this, we get c square is equal to 25. So that is nothing but c is 5. So this is actually the equation. This solution represents a set of circles, right? It is a circle, and the solution is y is equal to minus root 25 minus x square. Okay, so that is our solution of a differential equation, and in this case the initial value is given, and with the help of the initial value we can find the integrating constant. Now the third example, it actually gives us the concept about singular solution. We have learned different types of solution in earlier sections, and also here the heading itself is given how to lose a solution. So how can one lose a solution, right? That is we are going to find a particular solution of the given differential equation. So how can we lose a solution? Let's just see what they mean. So we are asked to solve in this example dy by dx is equal to y square minus 4, right? So here there is no variable of x on the right hand side. So when we consider this equation to be, we can write this as dy by y square minus 4 is equal to dx. Okay, now integrating of 1 by y square minus 4 with respect to y and integrating dx. So integration of dx is easy. So to integrate this side, you can either use the formula, direct formula, which is you can see what is the integral of 1 by x square minus a square. This is of that form, right? Y square minus 2 square. So you can use that, or you can partially you can use partial fractions to separate it. So while using partial fractions, so here they are using it, so we'll continue with this process. So when we use the partial fraction, this equation can be written as 1 by 4 divided by y minus 2 minus 1 by 4 divided by y plus 2, okay, into dy. So how do we get the value? That is 1 by 4 can be taken out common, and the integral of 1 by y minus 2 is nothing but log of y minus 2 minus 1 by 4 into log of y plus 2. Now log of a minus log of b is what? Log of a by b. So we get log y minus 2 by y plus 2 is equal to x. Integral of dx is x plus the integrating constant c1. So we'll have this 1 by 4 is remaining here. I'm going to take it on the other side, so I'll get 4 into x plus c1, that is 4x plus 4c1. Now I'm replacing 4c1 by c2. That's what we are we replace the constants according to our convenience. You can make the constant remain as it is also, there's no problem in that. So that will be equal to 4x plus c2. So to find the value of y, we have to take exponential on both the sides. So I get y minus 2 by y plus 2 is nothing but e raised to 4x plus c2. Okay, so simplifying this further, we get that is finding the value of y. So simplifying and finding the value of y, we get y is equal to 2 into 1 plus c into e raised to 4x divided by 1 minus c into e raised to 4x. Okay, so this is our general solution that we have found. This is a one parameter family of solutions that is y is equal to 2 into 1 plus c into e raised to 4x divided by 1 minus c into e raised to 4x. Now let's move back to the question that is given to us. Okay, we are asked to solve dy by dx is equal to y square minus 4. Now let me factorize y square minus 4. Once we factorize y square minus 4, we get this is equal to y minus 2 into y plus 2, right? So when I put y is equal to 2, the right hand side becomes 0, and when y is 2, derivative of y is also 0. So that is a solution. Y is equal to 2 is a solution. Similarly, y is equal to minus 2 is also a solution, right? these two are the solutions of this given differential equation. Now, so just keep that in mind. We have two solutions, that is y is equal to 2 and y is equal to minus 2. Now let's come back to the one parameter family of solution, that is y is equal to 2 into 1 plus c into e raised to 4x divided by 1 minus c into e raised to 4x. Now if I put c is equal to 0, what will be the value of y? Y will be equal to 2, right? So when c is 0, so this y, it actually depends upon the variable x only and the constant, whatever constant we put value. So if c is 0, I get y is equal to 2. But there is actually no value of c for which I can obtain y is equal to minus 2. So that is what they have given the heading of this example to be losing a solution. So that y is equal to minus 2 is but a solution of this differential equation. Okay, but that y is equal to minus 2 cannot be obtained using this family. This is a family. This family actually depends upon c. Like varying values of c, will get different solutions of y, different values of y, okay, in terms of x. So y is equal to minus 2 is a solution which is separate or which stays away from this family. So that is called as a singular solution. We have discussed about that, what is meant by a singular solution. So y is equal to minus 2 is a singular solution of the above differential equation. Now here we have another example, that is to solve the initial value problem. This is just a simple example. We are asked to solve the initial value problem. Cos x into e raised to 2y minus y into dy by dx is equal to e raised to y into sin 2x. So how can we separate it? I am going to take e raised to y to this side and cos x to this side. So I'll get e raised to 2y minus y divided by e raised to y into dy is equal to sin 2x by cos x into dx, and this is an initial value, that is y of 0 is equal to 0. So we can find the integrating constant. So what we are going to do is we are just going to simplify it. So this is nothing but e raised to 2y minus y, that is e raised to y minus y into e raised to minus y, and sin 2x can be written as 2 sin x cos x, so cos x will get cancelled. So the integration becomes much more easier. So here, what is the integral of e raised to y? It is e raised to y itself. What is the integral of y into e raised to minus y? We have to use integration by parts. That will be y into minus of y into e raised to minus y into minus y into minus 1. So that will be plus y into e raised to minus y into what is the differential of this? That will be equal to 1. So that is e raised to minus y. So here this portion you have to consider integration by parts, okay, by using ILATE, and the rest is easy. So we have e raised to y plus y into e raised to minus y plus e raised to minus y is equal to integral of sin x is minus cos x minus 2 cos x plus c. Okay. Now we are given y of 0 is equal to 0. That is, when x is 0, y is also 0. Now what is e raised to 0? E raised to 0 is 1, right? So we have 1 plus 1, that is 2, right? That will be equal to cos of 0 is again 1. So cos of 0 is again 1. So that is minus 2. So here we have 1. This is also 1 and y is 0. So this terms will become 0. So 1 plus 1, 2. 2 is equal to minus 2 into 1, that is plus c. So you get c is equal to 4. So our required solution, that is corresponding to this initial value, is e raised to y plus y into e raised to minus y plus e raised to minus y is equal to, instead of c we have 4. 4 minus 2 cos x. So this is our method of solving the initial value problems. So it's a very much simple process. We just have to find a way to separate the particular given differential equation into the separable form, into this particular differential form, right? And then we just have to integrate it, and relabeling of the constant, that is all up to your wish. It's just to make the calculations much more easier. So we shall be doing more problems on this, so to make the concept clear. So with this we shall wind up today's session. Thank you. Stay safe and stay healthy.